about the layout of a hydraulic brake system, where we have seen that you got to have the master cylinder, and then we had a short there was one question which was asked to me, sir, is there any different kinds of fluid which we have to use? So I just wanted to share with you that generally the fluid which is used for the hydraulic brake is the brake fluid must have SAE and DOT specification. DOT is Department of Transportation. Okay, but usually this Department of Transportation, they give the specification from the point of view of safety. That is first thing, and second, there should not be any evaporative emissions, because the emissions which are coming out from the vehicle, they are of two types. One is the tailpipe emission and the other one is the evaporative kind of emissions. So from that point of view, they keep an eye on the fluid which is used in the brake system or in complete vehicle. Even for engine oil, you have got this specification. Okay, so it should the viscosity should be such that it should flow at all the temperatures. That means basically this factor will come into picture when the temperatures are below 0 degrees centigrade. So this is for the cold region. Then the lubrication, that means it should not be too, like, let us say it should not have the viscosity too low and it should not have the viscosity too high, because in both the cases there is going to be some kind of lag or some kind of power loss, or you can say some kind of extra pressure which may be put onto the system. Then non-corrosive, this one can understand. Low freezing is also we have discussed earlier. Then water tolerant, this is basically the issue which is the critical issue. It says that it is the brake fluid is hydroscopic, which means that over a period of time it absorbs water, which lowers its boiling point. Should the fluid boil, air would form in the hydraulic system, resulting in the brake failure. That means if you do not maintain the continuity of the fluid and in between there is the air bubble which are trapped, then in that case the brake pressure which is applied by the driver may not get transferred uniformly, and then a high boiling point remains liquid at high temperature. That means there should not be any you can say deep in the boiling point temperature. So this is the idea on which the hydraulic fluid should work. Now let us come to the layout system. We have seen this as the layout system. Now today we are going to have the layout of the pneumatic brake system. So I will draw the layout of the pneumatic brake system, because yesterday we have drawn it for the hydraulic brake system. So today we will draw it for pneumatic brake system. So what do you expect in pneumatic brake system? So you can say block diagram of pneumatic brake system. The moment we say that the pneumatic, we understand that it is basically the air. So fluid used is basically air in this kind of system. So I'm going to draw. See, when we say that we want to transfer the motion, then we have to have the air compressor. Then after air compressor, there is some device. I will not name it. Let us check whether you know that device or not, because here you have to use the common sense of mechanical engineering. Then there is another device which you usually see this device when you go to the fuel station for filling of the air pressure in tire. So this is the, can say that the pressure gauge is attached here. So if you can name it, nothing like it. So this is pressure gauge. After that, there is a connection which is given to one component. Let us try to see if we can able to देखते हैं कि आप इसको पहचान पाते हैं कि नहीं। ये न्यूमैटिक ब्रेक सिस्टम के, so here the line is, the supply is given to, let us say, the actuator. So this you can say that कि ये सर्किट को जा रहा है, ब्रेक सर्किट। ओके, सो इसको ये कनेक्ट किया हुआ है। So this is rear brake. These are the front brakes. This is nothing but your brake wall. This compressor is driven by engine. I just want from you people that what are these two components? This component, what is this component and this component? Where I have made the dot, or where I am putting the, you can say, arrow or the pointer. What is this component and what is this component? सर थोड़ा आपको जनरलाइज्ड मैकेनिकल इंजीनियरिंग का नॉलेज रहना चाहिए, तो सर कॉमन सेंस से बताइए कि क्या रहेगा। वॉल एयर रिजर्वायर, ओके। तो सर एक तो करेक्ट है, ये एयर रिजर्वायर है। Why you require the air reservoir? Saurabh, you are right. First one is compressor, second one is the whatever second dot is there. I have said this is air reservoir. Why you require air reservoir? To store and maintain the pressure. Why you require to maintain and store the air at under pressure? Sir, use your common sense. Think as if you are a designer of this system. What about others? Are they sleeping? सर बाकी लोग सोए हुए हैं क्या? Please speak out. Unless you speak out, I am not going to move ahead. Evaporator, air filter. Okay. Saurav has given answer. Prajwal. What about others? सिर्फ 5-10 लोग ही देते हैं सर आंसर, बाकी के लोग सोए हुए रहते हैं. See, we keep the log of all the chats which are shared here. So all of you are requested to participate in the class. Yesterday we did the analysis and we came to know that only selected people they give the answer. Rest others they sleep in the class. Divesh, why you are late? Please answer. Divesh.
Yes, sir.
What is the issue? Internet issue?
No, sir, I was late.
Why, sir?
Sir, I lost the track of time. My fault.
What track you lost?
I woke up late. My fault.
Okay, I thought that it's a net issue. So others, please participate. Sir, please, I told you so many times to the students that every log is recorded on the cloud. So please be careful. Okay. So very only few selected people they answer, they interact. Rest all they sleep. This is the class of almost 70 students. And at a time there will not be more than, let us say, 60 or 65 students. So if there are only 61 participants are there, 9 students are absent in the class. Okay, so out of that only 5 or 6 they answer, rest all they sleep. So if you keep on doing that, please note that there is marks on the teacher's assessment. So please be careful. Because then it is easy for me to know that who has participated, who has joined when, who is leaving at what time. So I may suddenly say that there will be marks on the attendance. So please be careful. So this is basically this particular part is oil separator. Why you require oil separator? Because in compressor the lubrication is provided to the piston and piston ring and the cylinder inside surface, so that there should not be any metal to metal contact. So in that particular process the oil traces may come along with the air, and you require to separate that, otherwise it will go into the system and it may have the corrosive effect on the ball, it may have corrosive effect on the cylinders which are used for actuation of the brakes at the front and rear. Okay, that is basically the oil separator. So now the compressed air is coming from the air compressor, it is getting it is getting filtered in oil separator. Usually this unit is called as a FRL, that means filter, regulator and separator unit. So this is FRL unit which is used in the most of the pneumatic system, but here there is no need of regulation the air pressure because the pneumatic valve is there. So you can have the little bit of lubrication if required in the circuit, otherwise you need to filter out the oil droplets from the air and allow the air to get deposited in the air reservoir under some pressure P, so that when now suppose you run the vehicle and you park the vehicle, then on the when you again start the vehicle, then the compressor will generate the air under pressure, then it will get filtered, then it will move to the circuit. By that time the required pressure may not be reached, and that may cause that the brakes may not work when you drive the initially if there is no air reservoir. So air reservoir is must, because you need to have the supply of the compressed air or air under pressure every time, whether you start the engine or if you are not starting the engine at all. Okay, So such kind of requirement has to be met, and that is why you have to have the air under pressure, and that is why it is air reservoir is used. Now then there is a brake valve. Brake valve will control the, so this, there are three types of valve. One is flow control valve, the other one is direction control valve, and the third one is the pressure control valve. So this valve consists of the pressure control valve along with the controlling the direction of the flow. So the appropriate quantity of the air is given or inducted to the actuator of the brake system, and that is how you actuate the brake. So this is basically the pneumatic brake system which is used in most of the automobile engineering, most of the automotive systems or vehicle. Usually, see this system or pneumatic brakes, I can say, are mandatory to be used on buses and trucks. Government has made it mandatory. So when we were discussing the classification of the brakes, at that time I told you that the buses are very rarely fitted with the hydraulic brake, which was in the earlier days. But now government, by issuing the notification, it says that the pneumatic system has to be used on all buses and trucks which are plying on the road in India. So if you stop by a signal and if you see that the truck is stopped by your side, then just have the look at the chassis of the truck. You will find that there is some small cylinder which is fitted, that is, and on that particular reservoir there it is painted with the white color air tank, and there is some floral design on that particular tank. So make sure that it is nothing but the air reservoir. So I will show you why government has made this thing compulsory to be used on the buses. So this is, I'm going to share the PPT with you, don't worry. So this is the slide which will give you the idea regarding, see, if you read this, it says that why pneumatic brake system. As the load over light vehicle and heavy vehicle varies, the brake force required to stop the heavy vehicle is far more than light vehicle. So the heavy vehicles should be equipped with braking system that can provide the enough brake force that can stop or decelerate the vehicle. So this is the first point. So whether it is the new hydraulics or pneumatic brakes, this has to be made. So decelerate or stop the vehicle. For lightweight vehicles, hydraulic brakes provide more than enough brake force to stop or decelerate the vehicle due to its short dimension. But when it comes to the heavy vehicle, which are large in size, the effectiveness of hydraulic brake is the great concern. So the second point is the effectiveness of the hydraulic brake is saying that it's a great concern. As the fluid is used to press the piston in hydraulic braking system, the safety is the great concern. Again, they are reiterating that safety is a great concern. As if there is any leak in the components of hydraulic system, the efficiency of braking is readily reduced or even lost completely. Because please note that the hydraulic system you cannot top up immediately. Okay, you have to mechanically fill the hydraulic fluid. Since air is always available, so the brake failure due to leakage is less concern in the air braking system. Please note that the, if at all there is any leakage of the air, that can be always be compensated because the air is abundantly available. The components, master cylinder, brake line, etc., size of the hydraulic brake system increases with the increase in the size of the vehicle, which it in turn makes it very complex to install, which is not a problem with the air brake system. So pneumatic system you don't have the problem, but the problem is you have to have the engine, powerful engine, so that it can drive the compressor. Due to safety measures like brake failure and efficiency, government has made it compulsory. Please note that, as I told you, mandatory for heavy vehicles like buses and trucks. to use the air brake system. So this is basically the last point which says that considering this concern, the concern for the hydraulic system is size, the effectiveness of the brake system and leakage. So concern with the pneumatic hydraulic brake systems are, sorry, uh, एक minute. So concerns with hydraulic brake systems are, the first one is the effectiveness for heavy vehicle, the second is size of system components, and the third one is leakage of hydraulic fluid, which is oil. So because of this, the government has made it compulsory to use the pneumatic brake system in the heavy duty vehicles. So is there any concern about the pneumatic system, how it works and what is the layout and all? If do you have any question? Shall we move ahead? सर आगे चले क्या? चलो तो सर अभी कंपैरिजन ऑफ comparison of disc brake and drum brake. तो सर अभी ये कंपैरिजन देख लेते शॉर्ट में. फर्स्ट इज द डिस्क ब्रेक और ये हो गया आपका ड्रम ब्रेक. सर पहला कंपैरिजन, डिस्क ब्रेक इज हैविंग low inertia. This is compared with the drum brake. So here we will say that more inertia. Okay. Then more efficient cooling. Second, more efficient cooling. So here you can say that it is less efficient cooling. The effect of cooling is basically if you allow the heat generation, it is going to affect the frictional material. So small particle of disc is in contact with the brake pads and leads less brake fade. So this leads to less brake fade. Okay, this is related to the cooling. This is more brake fade. Okay. Then easy to service and maintain. Easy to service and maintain. So this is comparatively difficult. Difficult to सर्विस एंड मेंटेन. ये सर बाहर के बाहर निकाल के आप इसको सर्विस कर सकते हैं. इसका प्रॉब्लम ये है कि इट इज expensive compared to this is less expensive. So these are some of the positive and negative points of the disc brakes and the drum brakes. So sir, any questions on this? तो सर अभी आगे बढ़ते हैं क्या सर? नाउ ब्रेकिंग परफॉर्मेंस की तरफ जाएंगे तो ब्रेकिंग परफॉर्मेंस की बात करें क्या सर? सर एनी इश्यू? चलो आगे आगे बढ़ते सर, अभी ब्रेकिंग परफॉर्मेंस की बात करते कि ब्रेक का परफॉर्मेंस कैसे मेजर किया जाए. ओके सो let us do some analytical treatment for the braking performance. So sir, the general equation of braking can be written from Newton's second law of motion. Now this is for the motion of the vehicle. Let us say that this is the horizontal road and this is the vehicle moving in this particular direction. So you can say that the general equation the general equation of braking can be written from Newton's second law of motion. So sir ये बहुत ही जनरल इक्वेशन लिखेंगे और थीटा के लिए हॉरिजॉन्टल रोड के लिए we'll say that the theta is equals to 0. So let us say that mass into acceleration along x direction. This is given as minus w by g into dx, that is the deceleration, because when you apply the force so that has to be equal to minus f x f minus f x r. That means the front axle braking, rear axle braking minus aerodynamic drag minus w sine of theta. So this is the general equation. I will write down the meaning of each and every term in this particular equation. So w is the weight of the vehicle, then g is acceleration due to gravity, then dx is equals to minus ax, that is nothing but linear deceleration, because when you apply the brake the speed of the vehicle reduces down. fxr is given as front axle braking force, front axle braking force, which you can show it here. This is your fxr, sorry fxf, ये जो फ्रंट है ये फ्रंट एक्सल लिखा तो एफ एक्स एफ चाहिए, ये हो गया आपका एफ एक्स आर. सो एफ एक्स आर, तो इसको रियर कर दो, रियर एक्सल ब्रेकिंग फोर्स DA का मतलब है एरोडायनामिक ड्रैग, दिस इज aerodynamic drag, and theta is a fill gradient. So in the present situation, we will not consider. Now let us take the case. The first case is under constant deceleration. That means you apply the brake to the moving vehicle and the vehicle is decelerating with, that means there is no change as far as the deceleration value is concerned. So under constant deceleration, assuming forces acting on the vehicle will be constant throughout braking. Then we can say that this dx is equal to fx total now, front and rear, by m is equal to minus dv by dt, because the velocity is reducing. So here we can say that fxt is equals to total of all longitudinal forces on the vehicle, and v is basically the forward velocity. सर यहां तक के ठीक है क्या? तो सर अभी इसको इंटीग्रेट करते, अबाउ इक्वेशन एज fxt is constant, we have assumed that the braking force is constant throughout the braking. So if you integrate, then from here we can write down, so integral dv v initial to v final is equals to minus of fxt by m, because we have assumed that it is constant. So from 0 to ts, this is the dt. Ts is basically a stopping time. Okay, so ts is usually called as the stopping time, and vf is final velocity, and v0 is initial velocity. Okay, so from here there is a simple equation which you can get, that v0 minus vf initial minus final is equals to fxt by m into stopping time ts. So ये तो सर सिंपल एक्सप्रेशन आ गया. नाउ हमको स्टॉपिंग डिस्टेंस भी निकालना है. Okay, so this is from here you can get the stopping time. Now we also have, also these are the equations which you have I think studied already. So substitute for dt, dt के लिए substitute करो, so you can say that fxt by m is equals to minus dv divided by dx by v. So this is the substitute. Now if you do the term separation, fxt by m into dx is equals to minus v dv, and then you integrate this equation. So from here I am writing to this side, So integrate this equation V0 to Vf VdV is equals to minus of Fxt divided by M. इसको इंटीग्रेट करने के बाद इंटीग्रल 0 टू स्टॉपिंग डिस्टेंस x dx. ओके, तो सर ये आप इसको अगर करेंगे तो आपको फाइनल रिजल्ट मिलेगा v0 स्क्वायर माइनस vf स्क्वायर डिवाइडेड बाय 2. दिस इज इक्वल्स टू fxt by m into x, where you can have the x as the stopping distance traveled due to deceleration. Okay, if you are saying that the vehicle is going to stop at the end, so that is the distance which is covered. So this is x is distance traveled during deceleration. ओके, तो सर ये तो सर आसान हुआ अभी. So sir, in case now, just take one case. In case the deceleration is full stop, the deceleration stops the vehicle, that is Vf, the final velocity is equal to 0, then you can say that x becomes your stopping distance sd. So stopping, सर इसके ऊपर एक छोटा सा अच्छा प्रॉब्लम है, we will take that. So in that case your stopping distance xd comes out to be your v0 square divided by 2 times fxt by m. So this is equals to v0 square divided by 2 times of dx. This is the deceleration. So this is the expression. And stopping time, so stopping time ts is equal to v0 divided by fxt divided by m. So v0 by dx. सर यहां से एक चीज मार्क करिएगा, ये तो डेरिवेशन स्ट्रेट फॉरवर्ड है. We can do it at any point of time. This derivation is not a big deal, but the moment why we have taken this derivation, because now here we have said that the, please note that ये सब जो है हमने यहाँ ये जो एरोडायनामिक ड्रैग है ये अभी तक के हमने कंसिडर नहीं किया. So please understand that this is without considering the aerodynamic drag. So this is without the effect of aerodynamic drag. So now if we consider the aerodynamic drag, what is going to happen with the aerodynamic drag? What is your guess? सर अगर हमने एरोडायनामिक ड्रैग कंसिडर किया तो सर स्टॉपिंग डिस्टेंस में एंड स्टॉपिंग टाइम में सर क्या फर्क होगा इन टर्म्स, आई एम आस्किंग यू द क्वालिटेटिव डिफरेंस rather than the drag will decrease as the speed decreases. Okay, then the stopping time and stopping distance, sir, what is going to happen, whether it is going to increase or whether it is going to decrease? How do you calculate the aerodynamic? How do you calculate the aerodynamic drag? How it is going to affect? why you say that the vehicle body should be streamlined body, it is proportional to velocity square. Okay, Rishikesh, very good. So what about others, what they think? CF into V square by 2. What is CF, sir? Or CV square, skin friction coefficient or skin coefficient. Okay. चलो, तो सर मैं आपको एक थोड़ा सा इंटरेस्टिंग चीज बताता हूं कि जो आप लोग थोड़ा सा इसको एक्सपीरियंस किए होंगे और किए होंगे कि नहीं, आई कांट से दैट, बट ऑलमोस्ट मोस्ट ऑफ द पीपल दे एक्सपीरियंस दिस थिंग। ओके, तो चलो सर थोड़ा सा आगे बढ़ते हैं क्या? Sir, I'm just skipping to the proportional to effective area. Sir, you have said very correctly what is that effective area for calculation that we need to understand. तो सर मैं नेक्स्ट पेज पे शिफ्ट हो जाऊं? चलो, तो सर अभी थोड़ा सा एरोडायनामिक ड्रैग के बारे में सोचते हैं क्या है। सो aerodynamic drag. Sir, you know that the suppose ये सर व्हीकल है, okay, now the air is moving from this side with let us say velocity v, and as you said that कि जितना व्हीकल का वेलोसिटी होगा उतना ही एयर का वेलोसिटी होगा। if is the velocity of the vehicle, the velocity which is given by sorry the relative velocity concept से air का भी same velocity होगा, and you are saying that the drag force is equals to half CV A V square. Okay, this is the drag force. All of you agree? The coefficient of the drag, you can say that CD rather than CV. I will say coefficient of drag. So from here you can see that FD drag force is directly proportional to V square. And where you say that A is basically the, this is what is the area? Proportional to effective area. So A is, I will use this word, effective area. Okay, or you can say that the frontal projected area. Agreed? Yes. Okay, chalo, ठीक है. So that means if you draw the graph of the this with velocity, and if you see that FD, the graph, there is some road resistance component. I am talking about the total. This is your road resistance RA. This is the area of your drag force which increases with the velocity. Okay, so if I have to write down the equation, the total force of resistance is road area plus let us say your drag. Okay, this is CV square, so you can say that. So this in general I can write down that CV square proportional to CV square, correct? तो ये है सर। तो अभी मान लो ये जो फ्रंटल प्रोजेक्टेड एरिया की आपने बात की है, so this is basically the projected area is taken as geometric area multiplied by 0.9. तो सर ये याद रखना, ये ऑटोमोबाइल इंडस्ट्री में दिस इज द स्टैंडर्ड रूल विच दे फॉलो फॉर कैलकुलेटिंग द ड्रैग. नाउ आई विल ड्रॉ. तो ये तो सर आपकी बात हो गई कि भाई ये ड्रैग फोर्स है, दिस विल एक्ट और दिस विल अपोज व्हीकल मोशन. कि चलो यानी जितना ड्रैग फोर्स है तो ड्रैग फोर्स विल ऑलवेज एक्ट इन द अपोजिट डायरेक्शन. so if you say that this is the drag force, so this is going to act in the opposite direction. That means it is going to take out the fuel economy of the vehicle. now sir अभी मैं आपको just for your understanding कि मैं आपको ये एक व्हीकल बताया, सेम व्हीकल विथ सर्टेन मॉडिफिकेशन. let us say that this is the same vehicle with one modification. ये पीछे का शेप सेम ही है, ठीक है, ये समझो सेम व्हीकल है. नाउ हियर you may find that in the side view, if I draw the side view, ये sir just try to understand what I am trying to convey you. so यहाँ जो है, यहाँ एक nowadays you get the this they say at spoiler. सर गाड़ी में देखना आपने कि कुछ व्हीकल को ऐसा स्पॉइलर दिया होता है. सर व्हाट इज द पर्पस ऑफ दिस स्पॉइलर? this is across the width of the vehicle. so what is the purpose of this spoiler? to put it on ground. ग्राउंड में कैसा लगाएंगे सर इसको? ये तो व्हीकल के टॉप पे लगा हुआ रहता है सर, किसको ग्राउंड पे रखेंगे सर? ट्रैक्शन. ट्रैक्शन का क्या लेना देना है? प्रोवाइड अ फोर्स ऑन द कार एट हाई स्पीड. which how it is going to apply the force at the high speed? to prevent fluid separation. so उससे क्या होगा सर? कभी ना कभी तो if you are moving through the air, then there has to be some separation. अगर मैं यहाँ पे एयर का फ्लो पैटर्न निकालूंगा तो it will be like this. I'm just giving you the estimate of the एयर, यानी ये ऐसा जाएगा सर फ्लो पैटर्न. यहाँ क्या होगा सर? दूसरे केस में क्या होगा? the air is coming out like this, so it is moving like this. the spoiler is changing the air pattern, movement of the air. do you agree with the kind of streamline I have drawn for first and second? सर यहाँ ये भी लिखा था मैंने, करके नीचे से लिया, थोड़ा सा ऊपर से भी ले सकते थे. using aerodynamics, it will force it to remain on the ground at high speed and increasing traction. सर ट्रैक्शन अगर इंक्रीज किया आपने तो क्या होगा सर? ये ऐसे कैसे नीचे के साइड में रहेगा सर? सर थोड़ा सा आप सोचिए कि नाउ देयर इज गोइंग टू बी द फॉर्मेशन ऑफ, थोड़ा सा सर ये आप मार्क करिए, देयर विल बी रोटेशन ऑफ द एयर बिलो दिस. डू यू एग्री विद दिस? yes or no sir? say yes or no. yes. okay, now what will happen here? the rotation, the eddies will also be getting formed on the downstream side here. You agree? say yes or no. yes. So sir, which one you will prefer, the first one or the second one, and what is the effect of the first and second one? ये first है, ये second है. Sir, forget about traction and all, because the vehicle weight is such that the producing this kind of thing doesn't going to affect much. The airflow pattern से बहुत कुछ फर्क नहीं पड़ेगा. Traction and all, we will have to do it. See, usually ये vehicle का lift ज़्यादा बढ़ाएगा नहीं. That is one thing. That is how you can increase the traction, because that is how you design the racing car, wherein you limit the lift of the vehicle so that it should not get topple at the high speed. Okay, so we are not going to drive the vehicle at more than, let us say, 150 kilometers per hour. Okay, at least in India. For other side, I don't know. So here the basic difference is, if you in which vehicle would you like to sit if it is fitted with the canopy? That means the back side is open. So I am talking about this side which is open, and here this side which is open. Now imagine that you are moving on a rough road. Let us say you have gone for the jungle safari. So which vehicle would you prefer, the first one or second one? If you are moving on the rough road, so which vehicle would you prefer? Would you like to sit in first one or second one? The seating arrangement, every comfort which is there inside, that is the same. But let us say that the back portion of the vehicle is open in both the cases. So which one is good for you? Sir, थोड़ा सा common sense लगाइए. The second one. Why? Why? Sir, now since we have got limited time, let me answer your question that this distance is less and this distance is more. This distance is more. As a result, what is going to happen? The dust which was lying on the road, that will be getting lifted upwards, but at a larger distance. This D2 will be more. D2 will be more compared to D1. As a result, the backside of the vehicle will not be that much dirty compared to which you are finding out in the first vehicle. So whenever you are moving through the rough road, or if you are traveling on the rough road, then in that case the rear visibility will be better in the second vehicle compared to first vehicle. First vehicle में क्या होगा, जो धूल मिट्टी है नीचे जमीन की, वो whirling के कारण आपके बैक स्क्रीन पे आ जाएगी, और it may enter into the passenger compartment if you are sitting at the back and the vehicle is not having any you can say closing on the back side. Suppose it is having the canopy, so the first vehicle will become more dirty than the second one. So usually the spoiler, they are given to spoil or divert the airflow away from the vehicle body, because then there should not be any dust or dirt which should get accumulated on the backside. But usually most of the automotive people, they say that it is going to affect the fuel economy and all. So that is not the exact thing, because it is difficult to prove it mathematically. Okay, so today we'll stop here. If you have any questions, please do ask.